How's it going, YouTube? Dylan here. In this video, we're going to do number 339, nested list weighted sum. So you are given a nested list of integers, nested list. Each element is either an integer or a list whose elements may also be integers or other lists. The depth of an integer is the number of lists that is inside of. For example, the nested list 1, and then nested 2, 2, and then nested 3, unnest 2, unnest 1. Each has an integer value set to its depth. Return the sum of each integer in nested list multiplied by its depth. So here we're given an example here where we have 1, 1 that's nested, right? So that must mean that our depth here is going to be 2 and 2 respectively. Here we have 2, which is not nested, so that's going to be 1. And then we have 1 and 1, which is also nested, so the depth is going to be 2, 2, right? So basically what's happening here and what they're doing is they are multiplying it. So we're going to go 1 times 2 over here. And then 1 times 2 again, 1 times 2, right? And then we have 2 times 1, right? And then 1 times 2, and then plus 1 times 2. So this means that we're going to do 2 plus 2 plus 2 plus 2 plus 2, which is 1, 2, 3, 4, 5. That's going to give us 10, right? So let's take another example that is a little bit has a little bit more depth. So we can see here, given in the second example, that we have edge. Anyway, so we have 1, nested 4, nested, oh my god, nested 6, then unnest and unnest, right? So here our depth is going to be 1, right? Our depth here is going to be 2, and our depth here is going to be 3, right? So this is going to be 1 times 4 times 6 times, and then I'm going to change color here. So 4 times 2, right? And then 1 times 1, and then 6 times 3, right? What's that going to equal? Well, it's going to equal to 4 times 2 is 8. This one's 1. So 1, 8, and then 6 times 3 is 18. So that's going to be 27, which is our answer that we get over here. So visually speaking, when we're looking at this problem, instead of thinking it as a nested array, which can be very, very confusing, what we want to think of it as a tiered system, right? And it's going to make a little bit more sense once I draw the visual here. So we have 1 here, and this is at a depth of 1, right? And then we have a depth of 2. This is for the first example, by the way. And then the following values are going to be 1, 1, 1, and 1, right? And then that's basically it for that level, right? So what can we do here? I'll give you guys a hint. If I circle this, right, and then I circle this, I circle this, I circle this, and I circle this, and you know, I draw a little arrow here, and I draw a little arrow here, I draw a little arrow here, and I draw a little arrow here. What's that really an indication of? I'll give you some time to think about it. So this is going to be a good indication of our tree traversal algorithms that we know is going to be depth first search, and we're also going to have breadth first search, right? So these are the two little algorithms that we can use in order to find the ideal solution to this particular problem, right? So the question is, how do you do so? Well, for depth first search, we're going to code up that solution first, and what we're going to do is we're going to call it recursively. We're going to first determine if an integer exists, because remember, I'll give you a hint. I'll let you know, because this is basically the property of a nested list, is if you print the nested list over here, what you can see is that we have an integer value here, nested integer. This is actually the second example here. So anyway, the best example here would actually be the first example, because it's going to become very, very clear here. So you see here that this integer value is none, right? So why is it none? Well, because you're traversing that, you're kind of like skipping it because it's at a depth of 2. So it's almost like you don't see the values down in the nested list, and this is the reason why I drew the graph just like this, is because it becomes confusing when it's a nested list. As opposed to, say, if you were to do it like this, you would imagine like you had a pair of eyes here. Your pair of eyes only sees the 1, right? It doesn't see all the values down here, right? So we have to find a way to skip those values and just look at the 1 first, and then multiply that by our current depth. And then if we don't see anything here, let's just say that this one was empty, right? Then our little pair of eyes here would proceed to look at the next values, and they see, oh yeah, I see, 1, 1, 1, and 1, and then so on. It's almost like having the blinders on, only seeing like a certain amount of properties or amount of values, and then switching your vision in order to see the rest of the values. That's kind of how you want to think of it this way, right? So we're going to code up the depth first solution first, right? So what we're going to do is we're going to call our function first. So we're going to simply call it DFS. We're going to call a nested. I'm going to call the variable nested list. And of course we need our depth, right? Because we need to track those two values. So also what I want to track, remember, is the total. Because at the end of the day, we want the sum of each integer multiplied by its depth. So you can call it total, or you can call it answer, and we're going to initially set it as 0, right? So now what we want to do is we want to get each value inside of our nested list, right? So we're going to look over each value inside of our nested list here. So I'm going to redraw it here. 1, 1, 2, 1, 1. I'm going to go through each value inside of my nested list here, looking to see if it exists. If we have our blinders on, right? Can I see this? No, I can't. I want to have intentional blindness to it, but I want to see the 2, right? And I don't want to see the 1, right? If we looked at our nested list before, as you can see here, the integer is none, right? So what do we need to do? Well, for nested values in nested underscore list, what we're going to do is we're going to set an if condition. So if nested values dot is integer, right? And the reason why we're doing it is because you can see here that integer is none, right? So if integer is none, then we want to skip over it, right? then what's going to happen here? Well, we're going to have our answer. I'm going to add that to the current total value. So how do we do that? So, well, we're going to have nested values dot get integer, and that's going to help us retrieve the value that's listed. Where is it? Over here, right? And then multiply that by the depth, right? Else, we're going to recursively call the function again so that we set our blinders down to look at the second depth inside of the array here, right? And we're going to look at only these values. So if we take a look here, we see that we have intentional blindness to this one, but we're able to see this one and this one, right? So what are we going to do here? So we're going to add the answer to our recursively called DFS, which we're going to do nested values dot get list right, and then our second value is going to be depth plus 1, right? And then lastly, we're going to return the answer, right? And then our last area of business here is to simply call the function here. So DFS, we're going to do our nested list and 1, since we're starting at a depth of 1. So this is the depth first solution. Oh, let's see what we did here. Oh, forgot the return. And there we go. So we see here that it does work. Let's test out our test cases here, and let's run the code. And we indeed get the correct value. And let's click submit here. And we see that our runtime is 74. So this is an O of n solution with an O of n runtime space complexity. We didn't really use any additional memory here.